Alex here.
MoNaCo 2.
And good news.
Last
Good news.
lecture of the unit.
Woohoo!
Hope you've been paying attention.
Please.
Page 20.
Doing lots of practice on calculating molarity.
Mm-hmm.
Now we gotta check out colligative properties.
Basically, we understand what a solution is. We understand how things dissolve or dissociate. We understand how solubility of something can be affected by what ions it contains. How it can be affected by temperature too.
Right. But guess what?
Calculate concentrations. There's one little last piece.
That adding the solute can actually change some of the properties of the solvent itself.
Right, like, well, you kind of already know this. Like, water tastes like water, but you add sugar to water, it tastes like sugar water.
Right.
And if you add more sugar, the water gets thicker. Like, basically, fancy word colligative properties. It's like how certain things change when you, like Milk said, add solute to it, the solvent's properties change.
Right. Ever so slightly, but they change.
And here in the rock, this is a super important thing at this time of year.
Well, right, because it's icy out there, and we put something on the roads to
And the
change
sidewalks.
the melting point of the water.
Right. So what happens to the properties of a solvent when a solute is added? In general,
The boiling point goes up,
and at the same time,
the freezing point goes down.
so when we say colligative properties, we're really only talking about boiling and freezing point.
For our case and purposes right now, yes.
Right. We're not talking about the density. We're not talking about the viscosity. We're not
Good
talking. I love it.
I know what that is.
Yep, it's how thick something is.
Yeah,
We're not
resistance
talking
to-
about dumb.
No, we're not doing that.
Resistance to education. No, just kidding. So colligative properties are the boiling point and freezing point and how they change
Right.
when you add solute to your solvent.
Right. And what I want to make sure you guys know is both things happen even though I can only be at one point at a time to prove it.
Right. You can't measure the boiling and freezing point of the same sample at the same time unless you cut it in half.
But still, it's not the same sample.
Right. Even though, what if it was in one can? What if it was like a jar in a can, and you know it was all homogeneous and even throughout, and then you cut it in half and you froze one and boiled the other? It's not the same sample, really?
I don't know. Maybe, I guess, but it's still weird.
Yeah. Basically, what we're saying is you can't measure the boiling point and freezing point in the same instant.
Because it's two different temperatures. That's all.
So
But
how
they
does,
both happen.
But how does the concentration of the solute in the solvent relate to the effects of the boiling point, freezing point change?
Well, basically, the more stuff I put in makes me a higher concentration, the greater the change is going to be to the boiling point or the freezing point.
So if I add 1 scoop of salt to my pasta water versus 10 scoops of salt,
Right, the 10 scoops is going to make it boil at a higher temperature.
because there's a higher concentration, it's going to have a greater effect on the boiling and freezing point.
Yep.
Because it's a higher concentration, more solute per unit of solvent.
Right.
Okay.
And now this compounds with ions.
So you mean the dissolving and dissociating actually matters?
It actually, in this case, really matters.
Really
And
matters.
let's get into it just a little bit.
So ions, I know,
so if I put
dissociate.
in 1 mole
Uh-huh.
of any ionic compound,
It's going to dissociate after it dissolves.
right, and then I'm going to get whatever the number of ions in that compound were in solution.
So can I just draw real quick and see?
Well, we're going to do it on the next page.
Oh, all right.
Come on, we'll do it on the next page.
Okay.
But we can say it real quick, right? Like, so NaCl,
Would
It's
1
got
mole of NaCl contains,
2 moles of ions. 1 mole of Na ions, 1 mole of Cl ions.
and let's pick another one, you know,
Calcium chloride.
CaCl2.
Sure.
1 mole of calcium chloride, CaCl2, contains
1 mole of calcium ions.
and 2
2
moles of chloride ions.
So now I get 3 moles of
total
ions
moles
in
of
solution.
ions in solution. So
By
that's
putting
going
1 mole in,
you
that's
get
bang for my
3.
buck.
Right, so the effect is greater
So now the change in my boiling point and freezing point is going to be much greater.
when you put ionic compounds into it.
Correct.
The solvent we're talking about, water.
Water.
Yep.
So the and covalents are a little different because if I put in 1 mole of sugar,
C6H12O6.
I'm going to get 1 mole of sugar in solution.
Because it does not dissociate.
Right,
It just dissolves.
It stops at the dissolving, and so now I'm going to get this minimal effect. I'm going to get a change.
It will have an effect
Yeah, but relative,
to the ions.
now it's bang for my buck.
So you telling me if I was doing the CaCl2 thing, 1 mole of that solid produces 3 moles of ions in solutions versus sugar. In order to get the same effect, I'd have to put 3 moles of the sugar in
right,
versus 1 mole of the calcium chloride.
right.
I can
and-
already see a cost savings.
Right, and then sugar's pretty big compared to we're not-
Molecule-wise.
that- even the size, and we're not going to get into that, but the size probably has something to do with it too.
Most definitely.
So let's just show you real quick what we're talking about here at the bottom of the page. Ready?
So molecular things are covalent.
Right.
And
Oh, and I just noticed, look, I see how it says C12H22O11. Ooh, I didn't use that one as my example.
That's
Sorry
all
about you
right.
guys. I used regular glucose.
C6H12O6. What's that S in parentheses?
Solid.
So that's before it was added to the water. And the arrow means, that must mean dissolving in this case.
In this case, the physical reaction.
C6H12O6AQ. So that means that it has been dissolved in water.
Right, so and notice there's no number in front, so 1 mole of solid going in produces
1 mole of
molecules
solution. 1 mole.
Right.
Gotcha.
So now NaCl would be different. Notice that
chloride solid. So that arrow is the introduction of the water. And now we show you how it actually dissociated too.
right,
So
we have 2 moles of ions. Now you got
a sodium ion, aqueous,
and a chlorine.
Aqueous.
Cool. So now I have 2 moles of product.
So that's twice as effective in changing the boiling point and freezing point.
Correct. And we don't have to calculate that change anymore.
We used to be able to. It was a constant, though. I remember.
It was
a certain amount per mole.
But you had to plug it in, and this number is like the Hoffman. The 2 moles is a Hoffman distribution or something.
Had to figure some of that.
Yeah, there's
in the back of my mind, it was like the change was related to the number of moles.
It is grossly related to the number.
So there was like a conversion factor, like multiplication.
Right, and then boiling point elevation versus freezing point depression had another constant in there, which were grossly different because freezing point depression's lower, or much higher than boiling point elevation.
Right, it was challenging.
So again, we read this, right, the solute that dissolves to form the greater number of products or ions will have the greatest freezing point depression and the greatest boiling point elevation.
So calcium chloride solid becoming calcium aqueous ions and 2 chloride ions aqueous.
That's 3 total moles, okay? And then this is the reason why we don't put this on the road is because guess what? It's way more expensive than sodium chloride.
And especially here in this region, these compounds, calcium chloride, sodium chloride, they're minerals in the earth. We have to mine them out. About 35 minutes south of Rochester on 390, there is a massive sodium chloride rock salt mine.
Right.
And so it's cheap because it doesn't have to travel far to get to our city sidewalk streets. Calcium chloride, I don't know where the nearest mine is.
I don't know that honestly, I don't even know if they mine that. I think they make it, and that's why it's so expensive.
And when you go to the store, you can buy ice melt or rock salt. Ice melt is usually those little white circular pellets.
Isn't that calcium chloride?
Usually calcium chloride or some other
Ionic.
polyatomic ion situation because you're going to pay a bunch more, it better work better. Right? So
here's the best news about this unit, or this particular video. Not only is it done,
that's all there.
no math in this one.
None.
You just got to know that if I add anything to water, I'm going to change its boiling point and freezing point.
Boiling point goes up, freezing point goes down.
And we're going to use that in lab number 3 to make our ice cream.
Ice cream.
And I'll just say this one more time, remember? We're going to do ice cream one day for each class. You're not here that day, you're not getting ice cream.
Tough. You're not getting that lab, you're not getting those minutes.
Oh well.
Sorry.
Easy lab 2, by the way, because you get to eat it, and there's no CEI. Quick graph, you're done.
Right.
And again, if you want toppings, bring enough to share. Everybody brings some toppings. We can all share, and then we'll take care of the pieces that make the ice cream, and we'll be good.
Yeah. Thanks for watching this unit. Hope let's crank it out. I mean, this
Happy
pace,
unit, man.
my gosh, we're going to be done before Friday, I hope.
Well, you and I are.
Yeah.
See you guys.
Bye.